Hi everyone, in this video we're going to be interpreting slope. We're going to look at a bunch of different lines with all different types of slopes and compare the number that we get for the slope to what the line looks like. So let's begin with an example, as usual. So here I have two lines, line 1 and line 2. Line 1 goes through the points -2, 0 and the point 0, 3. And it also goes, and then line 2 goes through -2, 0 and 3, 1. So I want to first calculate each of these slopes, but we notice that line 1 is much steeper than line 2. If you think about if we were trying to walk up this line, it would be a lot harder than it would be to walk up this line. This is like the steep part of Horseshoe. This is like walking up a ramp to the student center. So let's see what that means in terms of the numbers we get when we calculate the slope. M1 is going to be the slope for line 1. So I do the usual thing. I'll do y1 minus y2 over x1 minus x2. So the change in the y values over the change in the x's. So if I look at the change in the y's between these two, that's going to be 3 minus 0. And then the change in the x values will be 0 minus -2. So that gives us 3 over 2 as our slope. As a decimal, this is 1.5. Now we'll get the slope of line 2, and that has points 3, 1 and -2, 0. So the change in the y's will be 1 minus 0, 1 minus 0. The change in the x's will be 3 minus -2, and that gives us 1 over 5. And 1 over 5 is smaller than 3 over 2, isn't it? 1 over 5 is smaller than 3 over 2. So our observation is that steeper lines, this one is steep, and this one we'll call shallow. Steeper lines have bigger slopes. That's our first observation about slopes. Let's look at this next example. We saw one like this in the last video. This is called a horizontal line. And how can we determine from the slope whether or not a line is horizontal? That's what we're trying to answer here. So let's compute the slope of this line. We can take 2 points, 1, 2, 3, 4, 5, 2, and -1, 2, for example. And the change in the y values will be 2 minus 2. And the change in the x values will be 5 minus -1. So this gives us 0, which tells us that horizontal line is the same as having slope equal to 0. Now let's look at this third example. This line is decreasing. It goes down. So what will that mean in terms of the number that we get for slope? Well, let's compute the slope. This is the point 0, 1, 2, 3, 4. And this is the point 1, -1. So the change in the y's will be -1 minus 4 over 1 minus 0. So the slope will be -5. Decreasing is the same as negative slope. When the slope is negative, we're going down. When the slope is positive, like in these cases, we're going uphill as we go to the right. One final example before we make some observations in writing. This is a vertical line. So vertical and horizontal lines have interesting slopes. We just saw that a horizontal line has slope 0. What slope will a vertical line have? Well, you'll notice that if a line is vertical, then any points on the line have the same x value. So same x value for all points on the line. So when I go to calculate the slope, if I look at the change in y, that will be 6 minus 2, over the change in x, that will be 3 minus 3. Then what do I get? I get 6 minus 2 is 4 over 0. This is undefined. A vertical line, because the x values will be the same, the difference in them will always be 0. So when we calculate the slope, we're dividing by 0, which is not allowed. So a vertical line will always have undefined slope. This line we would describe as just saying x equals 3. So we don't even have a y equals mx plus b way of describing a vertical line because there's no m. The slope is undefined. Pretty neat, huh? I think so. But I'm a nerdy math teacher. Okay, so here are some rules written in writing for your perusal. Maybe I'll also include a PDF of these rules just as notes. But let's read through them together. If the slope is bigger than 0, the line is increasing. So bigger than 0, the line is increasing. That's because the rise over the run, both of those will be positive numbers. If m1 is bigger than m0, so if we have two lines with different slopes, the one with the bigger slope will be steeper. You could also think about this with negative slopes. That's why we talk about absolute value. So this line will have this one will be more negative than that one. The absolute value of this slope will be bigger than the absolute value of this slope because this one's steeper. So maybe this one would be something like -5 and this one would be like -2. The absolute value of this is 5, which is bigger than the absolute value of 2. So bigger means steeper. That's what we're getting at. M equals 0, the slope is 0 if and only if the line is horizontal. So if you have a horizontal line, you know the slope is 0. If you know the slope is 0, you know you have a horizontal line. That's what if and only if means. It goes both ways. The slope is undefined if and only if the line is vertical. So if you have an undefined slope or an equation that looks like this, x equals blah, then the line is vertical. If the line is vertical, you know the slope is undefined and the equation will be x equals something. Two lines, now these two we haven't quite seen examples of yet, but we're going to in just a moment. So two lines are called parallel, which looks like this, if they have the same slope. So if you think about it, the rise here and the run is the same as the rise and the run of this one. They never intersect each other. So two lines can have the same slope and just be slid apart from each other. They're both equally steep. And finally, two lines are perpendicular, so they form a right angle. If the slope of one, so let's say we have m1 as our slope of one of them, then the slope of the other is minus 1 over m1. It's the negative reciprocal. So for example, y equals 1/2 x plus 2 is perpendicular to y equals, well, the reciprocal of this is 2, I flip it, and the negative reciprocal is -2, x minus 1. Let's look at another example of that a little more carefully. So basically what we're trying to do here is find an indicator of perpendicular lines. So if one slope is the negative reciprocal of the other, the lines are perpendicular. So let's do this example together so you can see it a little more clearly. I have 3 different lines that I want to graph. The first one has slope equal to 2/3. The second one also has slope equal to 2/3. The third one has slope equal to -3 over 2. So I flipped it and took the minus. From the rules that we just said, if they have the same slope, they're parallel. That says these two should be parallel. And it says that this one should be perpendicular to the others because the slope is the flip minus of the other two. So let's see, and let's graph these and look at the picture and make sure that we're right. So first we'll graph y equals 2/3 x. So the y-intercept is 0, because this is 2/3 x plus 0. And the slope is 2/3. So I rise 2 and go over 1, 2, 3 to get my next point. Let's do one more point just for good measure. Rise 2 over 1, 2, 3. So now let's connect this up using a straight line. Do my best here. And that's the line. Let's call this one y1. So this is y1. Now let's do y2. That's 2/3 x minus 5. So my y-intercept here is minus 5, 0. And I have the same slope. So I rise 2 over 1, 2, 3. And that gives me another point. When I connect those up, that will give me the whole line. And you can see y1 is clearly parallel to y2. They'll never intersect. So now let's look at y3, the one that's supposed to be perpendicular. This one has a y-intercept of 5, so that gives me 1 point on the graph, and it has slope -3/2, so I fall 3, 1, 2, 3, when I go over 2. Fall 3, 1, 2, 3, in order to go over 2. Okay, so I've got 3 points on my line. Now I'll connect them up. This is y3. And you can tell these are perpendicular. I could even do the paper test. The corner of this piece of paper fits perfectly into the intersection of those lines. So clearly these are perpendicular to each other. So our rule makes sense. So negative reciprocal, again, just means the flip and the negative. So that's what makes this line perpendicular to this one. Okay, so I hope this helps give you the link between how the number, which is the slope, can tell us about the picture. It tells us about things like steepness, about horizontal, about vertical, about parallel, and about perpendicular. So good luck on the web work. Please let me know if you have any questions at all.